All right, let's jump right in. We're going to explore a science that's completely invisible. But get this, it's probably in your house right now. It's in your clothes, maybe even in your body. We're talking about nanochemistry, the science of things that are unbelievably small. And believe me, it is changing, well, pretty much everything.
So, let me ask you something. What could your sunscreen, your smartphone, and, say, your favorite stain-proof shirt possibly have in common? I know, they sound completely random, right? But they all share this one incredible hidden secret.
And the answer? It's all about nanotechnology. It's like this invisible thread weaving its way through all these different things, from advanced medicine all the way to the packaging that keeps your food fresh. And this isn't some far-off sci-fi stuff. No, it's already here, working behind the scenes in your daily life. Okay, so to really wrap our heads around this, we need to think small, like really, really small. We have to go down to the nanoscale. So just how small is nano anyway? Okay, check this out. One single nanometer is 1 billionth of a meter. Try to picture that for a second. It's almost impossible, right? But that mind-bogglingly small scale, that's where all the magic happens.
All right, let's try to put that into perspective. Think about a single strand of your hair. Pretty thin, right? Well, that hair is about 80,000 nanometers wide. Now, a nanoparticle, the little building block we're talking about, can be as tiny as 1 nanometer. The difference in scale is just, wow, it's huge.
And here's where it gets really interesting. See, when you shrink things down that small, the normal rules of physics and chemistry, they just don't apply anymore. They start to bend, they get weird, and materials start to do some truly incredible things. Yeah, this quote really nails it. It means that stuff we think we know, like gold or carbon, can suddenly behave like a completely different substance. It's wild. And there are two big reasons why this happens. These two concepts are basically the engine driving this whole nano revolution. The first one is called the surface area effect. And the second one, well, that's where we dive into the strange world of quantum effects. So let's break them down. Okay, the surface area effect. Here's a super simple way to think about it. Imagine you drop a sugar cube into your coffee. It takes a little while to dissolve, right? Because only the outside can touch the coffee. But what if you crush that cube into fine powder? Poof, it dissolves almost instantly. Why? Because you've just massively increased the surface area. It's the exact same idea with nanomaterials. When you break a big piece down into millions of tiny nanoparticles, suddenly way more atoms are on the surface, ready to react. It makes the material supercharged. So what's the bottom line? More surface area equals way more reactivity. And that's exactly why nanoparticles are game changers as catalysts. They can speed up chemical reactions like you wouldn't believe, which saves a ton of energy and resources. All right, now for part 2, quantum effects. And this is where things get, well, kind of mind-bending. So we all know what color gold is, right? It's yellow. But what if I told you that if you shrink gold down to the nanoscale, it can turn red or even purple? It's still gold, but at that tiny, tiny scale, its electrons start playing by quantum rules and interact with light in a totally different, bizarre way. So, okay, we get why nano is so special. But the next big question is, how on earth do scientists actually build things that are so tiny? It's like this incredible art of nanoscale construction. And they basically have two main ways of doing it. So you've got two main approaches. First is top-down. Think of a sculptor with a block of marble. You start big, and you chip away everything you don't need. The second approach is the complete opposite, bottom-up. This is like building with Legos. You start with the tiniest individual pieces, atoms and molecules, and you click them together one by one to build exactly what you want. And honestly, that bottom-up approach, that's where the real power of nanochemistry is. It gives scientists this incredible, precise control to literally design and build materials from scratch, materials with brand new properties that are tailor-made for a specific purpose. Okay, so let's zoom back out from the lab. We've talked about the why and the how, but let's get to the what. Where is this tiny tech actually showing up in our world? Well, spoiler alert, it's already everywhere. I mean, just look at this breakdown. This isn't some tiny niche science. It is making huge waves across so many different fields. We're talking medicine, electronics, consumer goods, even the energy and food industries. It's a really big deal. So let's bring it back to that question from the beginning. That sunscreen,
It's loaded with titanium dioxide nanoparticles. They're amazing at blocking UV light, but they're so small you can't see them, which is why modern sunscreen is clear, not pasty white. That stain-proof shirt? Yep, coated with a nano layer that literally makes water and stains beat up and roll right off. And in medicine, this is amazing. We're talking about nanoparticles that can hunt down cancer cells like tiny guided missiles, delivering medicine right where it's needed. And of course, your phone is packed with nanoscale components, making it faster and more powerful.
Now, look, with any technology this powerful, you have to be realistic. We have to look at both the promise and the problems. On one hand, the advantages are huge, right? Better products using fewer materials, maybe even some real eco-friendly wins. But on the other hand, there are big questions we still need to answer about potential health risks or what happens when these materials get out into the environment. It's a conversation we absolutely need to have.
And if we look down the road, man, the potential is just mind-blowing. Right now, it's advanced materials, but soon we're talking about smart drugs becoming a common thing. And then maybe nanorobots that can perform surgery from inside your body, or even building artificial organs from the ground up. It's a whole new frontier.
So that kind of brings us to this one big final thought. For the very first time, we're learning how to build our world not with bricks and mortar, but atom by atom. We have this incredible new toolkit, so the question for all of us is, what should we build first?